Have you ever wondered how much water flows in a river, or how that flow changes after a big rainstorm? That's where hydrographs come in. A hydrograph is like a graph that tells the story of water flow over time. It's a simple but powerful tool used in water resource management. Hydrographs show us how much water is flowing in a river or stream at a given time. They help us understand how rainfall, snowmelt, and other factors affect water levels. This information is crucial for managing water resources effectively. By studying hydrographs, scientists and engineers can predict floods, manage water supplies, and design structures like bridges and dams. So, let's dive in and learn more about these fascinating graphs. Just like there are different types of cars, there are different types of hydrographs. Each type gives us unique information about water flow. Let's look at some of the most common ones. First up, we have the stream discharge hydrograph. This type shows us how much water is flowing in a stream at any given time. It's like the speedometer of a river. Then there's the stream stage hydrograph, which tells us the water level in a stream. Think of it as a measuring stick for rivers. Another important type is the precipitation hydrograph. This one shows us how much rain or snow falls over time. By comparing this with a stream discharge hydrograph, we can see how rainfall affects river flow. Pretty neat, huh? Building a hydrograph is like putting together a complex puzzle. We need two main pieces of crucial information: time and water flow. Time goes on the x-axis and water flow goes on the y-axis, forming the basis of our graph. To get this essential information, scientists use special tools like stream gauges. These gauges are placed in rivers and streams to measure the amount of water flowing past a certain point. They record this data over time, giving us the pieces we need for our hydrograph puzzle. Once we have our data, we can plot it on a graph to visualize it. The resulting line shows us how water flow changes over time, giving us a clear visual representation of the river's behavior. Section 4. Interpreting hydrographs. Now that we know how to build a hydrograph, let's learn how to read one. Interpreting a hydrograph is crucial for understanding the dynamics of a river system. It provides insights into how water flow changes over time, which is essential for managing water resources and predicting flood events. The shape of the hydrograph tells us a lot about the characteristics of a river and its surrounding watershed. For instance, a sharp peak might indicate a river that responds quickly to rainfall, while a more rounded peak suggests a slower response. A steep rising limb on a hydrograph indicates a rapid increase in water flow, usually after a heavy rainfall event. This can be a sign of a watershed with little vegetation or impervious surfaces, which causes water to run off quickly. This means the water is moving quickly from the land into the river. Such conditions can lead to flash floods, which are sudden and can be very dangerous. On the other hand, a gently sloping falling limb suggests a slower decrease in flow, indicating that the water is taking longer to drain from the watershed. This can be due to factors like dense vegetation, wetlands, or permeable soil that absorbs water. By analyzing the shape, slopes, and other features of a hydrograph, hydrologists can gain valuable insights into the behavior of a river and its response to rainfall and other hydrological events. This information is vital for flood forecasting, water management, and understanding the ecological health of a river system. Section 5. Applications of hydrographs. Hydrographs are incredibly useful tools with a wide range of applications in water resource management and beyond. Let's explore some of the ways these graphs help us understand and manage our water resources. One of the most critical applications is flood forecasting. By analyzing hydrographs and rainfall patterns, hydrologists can predict when and where floods might occur. This information is crucial for issuing timely warnings and evacuations, potentially saving lives and property. Hydrographs also play a vital role in water supply management. They help us understand how much water is available in rivers and reservoirs, allowing us to make informed decisions about water allocation for drinking, irrigation, and other uses. Section 6. Advanced techniques in hydrograph analysis. As we delve deeper into the world of hydrographs, we encounter more advanced techniques for analyzing these valuable graphs. These techniques are crucial for hydrologists and water resource managers who need to make informed decisions based on accurate data. These advanced methods provide even greater insights into the complexities of water flow and help us refine our understanding of hydrological processes. By employing these techniques, we can predict and manage water resources more effectively. One such technique is hydrograph separation. This method is fundamental in distinguishing the different sources of water that contribute to stream flow. This involves separating the different components of a hydrograph, such as base flow and direct runoff. Understanding these components is essential for accurate hydrological modeling. Base flow represents the groundwater contribution to stream flow, which is a critical factor during dry periods when there is no rainfall, while direct runoff comes from rainfall or snowmelt that flows directly over the land surface. This component is particularly important during storm events and periods of rapid snowmelt. By separating these components, hydrologists can better understand the sources of water in a river and how they contribute to stream flow during different hydrological events. This knowledge is vital for predicting flood events and managing water resources. This information is essential for accurate water balance calculations and sustainable water resource management. By applying these advanced techniques, we can ensure that our water resources are managed efficiently and sustainably for future generations. Section 7. Useful tools and resources for hydrograph analysis. In today's digital age, we have access to a wealth of tools and resources that make hydrograph analysis easier and more accessible than ever before. These tools are not only user-friendly but also incredibly powerful, enabling both professionals and enthusiasts to delve deep into hydrological data with ease. These tools range from online databases and software packages to sophisticated hydrologic models. They provide a comprehensive suite of functionalities that cater to various aspects of hydrograph analysis, from data collection and visualization to simulation and prediction. One such resource is the USGS WaterWatch website, a treasure trove of hydrological data, including real-time stream flow information, historical hydrographs, and other valuable resources. This platform is indispensable for anyone involved in water resource management or research. Another essential tool is the National Weather Service's Advanced Hydrologic Prediction Service, or AHPS, which provides flood forecasts and warnings based on hydrograph analysis. This service is crucial for communities prone to flooding, offering timely information that can save lives and property. For those seeking more advanced analysis, various software packages are available, such as HCHMS and SWOT, which allow hydrologists to simulate hydrological processes and predict stream flow under different scenarios. These tools are invaluable for conducting detailed studies and developing effective water management strategies. These tools empower us to make informed decisions about water resource management, flood mitigation, and environmental protection. By leveraging these advanced resources, we can better understand our water systems, anticipate potential issues, and implement solutions that promote sustainability and resilience in our communities.